So hi everyone, thanks for joining us today. This is the version control workshop that we're running. So I'll introduce Women in STEM very quickly. The aims of Women in STEM are to promote equality, diversity and inclusion across all STEM fields, to provide skills workshops and opportunities, and to create a network of members and industry professionals for tips and advice. So a couple of the past events that we've run have been the Hello World Hackathon. It's been one of our bigger events. It's an introductory hackathon, and more experienced people can get involved with being a mentor with that, and we're hoping to run that this year as well, or rather in 2021, next year. The Women in STEM Connect series was something that we ran over summer to keep everyone connected, especially during lockdowns. The internship fair was something we ran more recently, and that was done virtually this year. And we had students talking about their internships over summer, especially them being virtual this year. The Big Question series in physics is continuing, and we have another event in that series coming up next week. And some more social events that we've done have been the escape room and Kaylee. So those are obviously something that we're still trying to do. We have coffee mornings now, which we're trying to run every month to keep everyone more connected socially. These are some of the upcoming events we have, which I'll go over at the end very quickly as well. And these are our socials, and you can find everything on our website, euwithstem.com. I'll hand over to Samuel now. Stop sharing my screen there.
Hello. I will start sharing my screen and hopefully that'll work. There, can you all see that? No?
No. Oh, yeah.
Yes?
Yes.
Wonderful. You get the slides. Yes.
Yes, we can
Wonderful.
see the slides.
Just wanted to check. Okay. Yeah, so let's talk about Git. I'm Samuel. You can probably all see me, but here's another picture of myself with my dog. And yeah, I'm a math student here, and let's dive into it. Oh, that's highlighted. Wonderful. So, what is Git? Git is a version control system. So it's something that keeps track of changes in your code as you go, preserving the history and keeping it safe. It lets you go back through different versions of your code, and it helps with collaborative development because it can keep track of the authorship of who wrote different bits of your code. So that's a kind of brief intro into the high level of what it is. But for the next wee while, we're going to be talking about pirates, and we might loop back to Git a wee bit later on. So the pirates. So there was once a pirate called Long John Silver. Now you might know the name from Treasure Island, but there's no relation at all. Now Long John Silver, he was quite the gold digger, and he'd managed to acquire a very accurate treasure map. Which, as you all know, is usually very difficult. He had quite a rivalry with other pirate crews, though, and he didn't want anyone else to find out about his precious treasure map. And so he came up with a plan. He was going to hire an artist to make lots of fake treasure maps to throw his competitors completely off the scent. And so he did. He hired an artist, Jane Smith, and asked her to make hundreds of fake treasure maps. Now let me set the scene. So Jane was left on a remote island with all the materials she needed and asked to get started, and so she did. She toiled day and night to make some real progress in these fake treasure maps, and yeah, it was all working fine. Unfortunately, there was a rather large storm, and all her progress was wiped away. All the treasure maps were thrown into the sea, and she lost everything. Now, Long John Silver and his crew came back. They restocked the island with the materials, but they didn't want to be caught out like that again with another storm. So Jane devised a plan, and let me walk you through it. So, first off, as Jane worked on these maps and finished section after section, some trees there, a hill there, and so on, she piled up all the maps she'd worked on by her side. And then every day, at the end of the day, all the maps she'd worked on that day, she gathered them all up, climbed the hill in the middle of the island, photocopied each map she'd worked on, and let's put aside the incongruity of pirates having a photocopying machine. Let's just leave that. And she buried all the maps she'd worked on that day in the hill. Like that. So that meant she had a copy of the maps that she'd worked on kind of each day, buried in the hill, safe and sound. There's still an issue though, because what if the island itself had an issue? There was an earthquake, or the hill erupted as a volcano. So finally, the pirate crew, every couple of days, they came, they dug up the hills, not the hills, the maps from the hill, and they shipped them off to another island where they buried them in that island. So now you had a copy of the maps off on another island, in hill in this island, and then whatever Jane was working on as well. So you had 3 copies. Now, how does this relate to Git? So this is essentially what Git is, and I realize that may sound a bit odd. So we're gonna dive more into that. But there are kind of 3 main concepts with Git. There's the working directory, the staging area, and the repository. So the working directory is what you're working on right now. Your kind of set of files and folders you're working on right now. Your staging area is what's ready to be saved, and your repository is kind of where stuff is saved. So relating that back to the pirates, the working directory are kind of, the maps that Jane is working on right now. All of them kind of just strewn around, whatever changes she's making. The staging area is the ones she's made changes on, she wants to save. So that's the kind of pile she's put up beside her. So I've put up the 3 areas on screen again. So that's the pile she's put up beside her. The staging area is the pile she's put up beside her. The repository is the hill itself. So that's where you've stored all the changes you've made and you've buried them into the hill. And then finally, the third one is a remote repository. So that's just another copy of your repository somewhere off in the distance, completely safe and sound. And that's kind of the 3 main concepts with Git. You've got your stuff you're working on right now, you've got the stuff that's ready to be saved, and then you've got the stuff that is saved. And then multiple copies of that has been saved over time. I'm waving my hands around here, but I realize that it's below my camera, so you can't see that. So I apologize for that. Yeah. So unfortunately, we're gonna have to move a wee bit away from the pirates now and look at the command line and the terminal, because those are the kind of main tools you'll be using to interact with Git. So there are 3 commands that move stuff between these areas within Git. So when you have files in your working directory, which is kind of the stuff you're working on right now, you have to run git add on those files. And don't worry, I'll go more in depth on these later on. And you can see how these move around. You'll have to run git add on those files to move them into your staging area. So that's the stuff that's kind of ready to be saved. Then you'll have to run git commit on that staging area to store that as kind of a copy of the files, a state in time. And that puts in your repository. And then git push takes your local repository, whatever you have stored in your own hill, and moves it over to the remote repository, another island, and buries your files over there. It doesn't actually bury them, but you can think about it as burying them. Right, so let's go through an example with some files and folders rather than maps and hills. So here's a folder called Git, and it's got some files in it, hello world.haskell, and a readme markdown file. So I've got the kind of main areas here. You can see your working directory, all your files up in the top right corner, unless this video is flipped. I don't think it is. Okay, and then in the bottom left, you've got your remote repository, your local repository, and your staging area. And then in the top left, you can see the command that's being run. So if we run git add hello world.
Sorry to interrupt, it is flipped.
Oh, it is flipped. Oh, that's not good. Wait, so you can't read the text then?
We can read the text, but the top left is the command.
I see. Okay. Well, wherever I'm pointing, yes. Okay, well, take this command. So git add hello world.haskell. So that adds the hello world.haskell file from your working directory, from your local kind of files and folders into your staging area. You can see it there. It doesn't like move it out of your working directory. It kind of duplicates it in the staging area. Now, you can also add your README file, but in a case like this where you're adding everything to your staging area, there's a couple of shortcuts you can use. You can do git add dot, which adds everything in your current folder to the staging area, or you can do git add -- all, which adds all files into your staging area. But to loop back to just having the hello world Haskell in your staging area, to move that into the actual repository itself, we'd have to commit that. All those changes in the staging area, we want to commit them to the repository as a kind of marked change. So we run git commit with the M flag, so -m, and then a description. So this description is kind of describing not necessarily what's changed, because that's usually clear from the files, but more about why it's changed and what the reasoning was. So if there's a bug in your software you're fixing, you could describe what the bug was that this fixes. If there's a new feature you're adding, you could describe what that feature is, why it's being added, or something like that. There's a couple different options there. And there are multiple different style guides for commits online I'm sure you can look up. It kind of depends on the project you're working on, what becomes useful there. So that will move everything from your staging area into your repository, and you can see it move down there, hopefully, if the slides are working. Yeah, so finally, git push. This is the kind of the pirate ship taking your files from the hill, taking them over to another island. So it's important to note here, this doesn't move anything. This doesn't move from your repository to the remote. It duplicates from your repository to the remote. So you don't lose any files. You've still got all your files locally, but you've also got them somewhere off in the distance. And that's a really important feature of Git. Every kind of local copy of the Git repository has everything. So if you've got kind of a remote repository with a bunch of files and loads of people have copies of it, they all have all the files. There's no kind of mixing and matching there. So if for some reason your remote repository has an issue, then you can go to someone else's local repository and try and rebuild the remote. Yeah, so to go through a couple more commands, and then we're going to do a bit of a live demo. Git log, this is a command that kind of gives you an idea of what's happened. So this will give you a log of all the commits that have happened in your repository. So you can see the ID of the commit, that's quite long, and you generally don't need to remember that. It gives you the author, so that's kind of whoever made that change, obviously. That's me. I didn't realize that would put my email address on the slide, but please don't send spam emails. It also gives you the date and the commit message, so whatever the change was. Describe the change as a really terrible commit message. Please use a better one, but that's just an example. So git status gives you the current kind of status of your repository. So it tells you what things are in your working directory and not in your staging area, what things are in your staging area and not in your repository, and what things are, things like that. So you can see here untracked files. So this is all the files that are in your working directory but aren't tracked in your staging area. So that's just readme.md. That's the file that I haven't added. Yeah. So remote repository hosting. There's a couple different options here. You can set up this yourself, just set up another Git repository off in another machine somewhere. But for kind of reliability, it's generally best to use an established service that hosts that for you. There's a couple different options: GitHub, GitLab, Bitbucket. GitHub is probably the one you'll have heard of. It's the most popular. It's the one I'll be showing later on today. But you can use any of them. They're pretty much kind of feature compatible. There's not much difference between them. Okay. Okay, I put live demo there, but I meant to put questions there. Does anyone have any questions at this stage? If you do, put them in the chat or unmute yourselves and put your video on and ask it if you'd like. No? None at all? Wonderful. Okay. Live demo. Okay, I appear to have included that slide twice, but never mind. So I'm going to do a live demo. I'm going to go through kind of how to use GitHub and then go through these commands that I haven't introduced quite yet, but will hopefully make sense as we go on. So git clone, git pull, git checkout, git branch, and git merge. They will all hopefully make sense. And if you do have any questions, put them in the chat or kind of raise your hand, and I'm sure we can get to them at the end. Alrighty, so creating a new repository. So this is a GitHub account. I'm not going to dwell too long here because this is my GitHub account. Right, so creating a new GitHub repository. Yeah, so you give it a name. So I don't know, demo, give it a description. Whether it's public or private, so whether it's visible to the world or just for you. I'm going to leave this as public. You can go find it later on if you want to. Create repository. Righty-ho. So this will give you an idea of how to use your local Git repository and make that a repository on GitHub. So now we're going to move away from this slightly and look at how to set up a local Git repository. So I hope you can all see this. Yes, wonderful. So this is Visual Studio Code set up with these files, hello world.haskell, readme.md, and a terminal, which I have not cleared. So we're going to add some text to, so this isn't a Git repository yet. This is just a normal folder. So the first thing you want to be doing is you want to be initializing this as a Git repository. So it's really simple to do that. You just open a terminal and in the folder run git init for initialize. And that's it. So now you've got a Git repository. So now you can run git status. And you can see the ones that, you can see the files that haven't been put in the staging area that are still in your working directory. So that's both of your files at this stage. That's readme.md and hello world.haskell. And if I added a new file, you could see that turn up as well. Yes, you can see that new file. It would help if I could spell, but you can see that new file turn up there as well. Alrighty, so let's add some content to one of these files. So I'll make that slightly bigger. So if I save that and run git status again, it's still there. So if I add that file readme.md to my staging area now, so with git add, is this text big enough, by the way? Yes, wonderful. So git add readme.md. So that's added that file from my working directory to my staging area. So you can see with git status. Yeah, so you can see with git status that in your staging area, you've got readme.md, and then in your working directory, so that's not in your staging area yet, you've got these two files. Alrighty, so if I wanted to commit that change, if I wanted to say, right, this is an actual change that I made that I want to be tracked with a description, I could do git commit with a message of, and again, this is a terrible commit message. Please try and use, more descriptive ones when you're actually writing code, but this is just for demonstrative purposes. Alrighty, so git commit. So now if we run git status again, you can see that it's only showing you these things that haven't been tracked. Now if we run git log, which if you remember, it shows you all the commits that have happened in this repository. You can see that, which is the first commit that I've just made, the date it was made, what the description was, and what its ID is. Alrighty, so let's try and link this to our remote repository now. Let's try and link this to GitHub. So GitHub is really quite helpful with this. It gives you essentially some commands you can copy and paste and run in your terminal. It's generally not a good idea to copy paste commands from the internet and run them in the terminal, but in this case, GitHub is fairly trusted, so you should be able to. But in most sites, don't copy commands and run them in your terminal because that can lead to some really bad things. Alrighty, so I'm just going to paste these in. I have not copied them. Okay, I'm going to copy them and paste them in. There we go. Okay, so you can see this hasn't affected the commit log. The status is all the same, but now this is linked to GitHub. So we've got a command called git remote. Okay. There's a command called git remote, not remove, remote. You can pass the v flag to give a bit more information, and that shows you all the kind of remote repositories that have been linked to this local repository. So this one is called origin, that's the default name, and this is where it is. So that's just the GitHub link. You can see there's two instances here. One is for pushing, one is for pulling. So one is like putting code to the remote, one is taking code from the remote. You generally want them both to be the same, and Git will kind of do that for you. Alrighty, so if I want to push local code to the remote repository, I can do git push. Okay, well that seems to have not quite work. Yes, there we go. Perfect. Alrighty. So now you can see on GitHub the changes that I've actually made. Now you can only see the readme.md file because that's the only one that's been added to the repository and committed. If we wanted to add the other file, so the hello world.haskell file, we would have to change that, add some stuff, and commit that as well. So I'll do that now. It's been a while since I've done Haskell. I think this is valid syntax. It's probably not, but that doesn't quite matter. Right, so if we look at git status, you can see that hello world.haskell and new file are still untracked. But if we add hello world.haskell, so git add hello world.haskell, let's done that, and then git status, you can see that hello world.haskell is now in your staging area. It's ready to be committed. So you can commit that. So git and you can see the log. So now there are two commits in the log. There's the one we made earlier, and then this one right here. But that hasn't changed in GitHub yet because we haven't pushed it. So GitHub still shows the same. If we want to make those changes in GitHub, you have to run git push. And there you go. So you've got your GitHub, you've got your Git repository on the remote on GitHub, and you've also got it locally here. Alrighty. So does anyone have any questions at this stage? Malvika, I don't know if you've seen any questions in the chat.
Yep, I can read them out. Someone's asked, may I ask what are tags and branches in Git?
Sure. We'll go on to talk about branches, but I don't think we're going to get to tags today. I'll point you to some links at the end where you can read more about those. Anything else? Or we can move right on to branches. Alrighty. So the next kind of major thing with Git is branches. So in the same way that you've got kind of a working directory, staging area, and your actual repository, and then a remote repository, branches are kind of another area within that. So when you've got two people working on something, they're generally kind of making changes at the same time to maybe the same stuff, maybe different stuff, but they kind of want to be working on the same code, but making independent changes, then kind of pulling those changes in together once they're made. So branches are kind of like a separate copy of the repository that everyone has, that's slightly different from the main copy in the changes they're making. They'll then be kind of pushed back into the main copy. Alrighty, so let me split this terminal and we can see. Okay, so the way to check what branch you're on in GitHub, in Git, sorry, is to run git branch. So the default branch in Git is master. GitHub changes it to main. It's basically going to be either master or main, depending on what system you're using. So you start off with just one branch, the main branch. If you want to create a new branch, you run git branch and then the name of the new branch. So that's created that new branch. And then if we run git branch again, you can see that new branch is there. The git branch command is quite handy, and then it tells us which branch we're on right now. So you can see the main branch has got a star next to it and it's green. That's the one we're on right now. And new branch is just a separate one lying around. So if we want to go on to the new branch, you run git checkout and then the branch name, so new. And that's, now we're on that branch. So it's kind of important to note that not a whole lot has changed about this stuff here, because branches don't kind of, when you create a branch from a commit, everything is the same. Like the copy of the files are exactly the same. So nothing has changed here. However, if we do make a change here, so, and again, I'm aware I'm butchering Haskell, but let's leave that aside. So now we can see status. So we can see we've changed hello world at Haskell. We're gonna okay, so now you can see that we've made 3 commits here. We've made the initial one, the second one, and then this one we've just made here. And it's quite important to note in this git log output that it tells you where each commit is in terms of the branches. So our kind of initial branch, our main branch that's on GitHub right now is here. It's called origin/main. And that's where also the main branch is. But this branch that we're on right now is called new branch, and that's the kind of latest copy. Now, if we wanted to switch back to the main branch and make some changes there, or to pull in these changes from new branch, we can do that. So you can run git checkout main, which will take us back to the main branch. And you'll notice that the changes we made in new branch aren't there anymore. They're gone. Sorry, they're still stored within the Git repository, but they're not in this branch, so we can't see them right now. And then if you run git log, you can see you can only see the commits that are on this branch. Yeah, so that means that someone can work independently on a different branch, on different kind of sections of the code, and make changes that don't affect what you're doing. And then only once you're actually ready to kind of pull them together will you actually do that. So yeah, once you're ready to pull branches together, kind of pull the new branch back into the main branch, how do you do that? Well, that's the git merge command. So you run git merge. So you run this from the branch you want to be the one that stays. So you want, if you're in the main branch and you want to pull into the main branch or merge into the main branch, new branch, then you would run this command in the main branch. So we can double check we're in the main branch. Yep, we're in the main branch. So we can run git merge new branch. So that's going to pull in all the commits from new branch into the main branch. Yeah, and you can see that that change is now here. We can verify we're still in the main branch. Yep, we're still in the main branch. And now we can see in the commit log all the commits from new branch. Alrighty, so however, if we go check back to GitHub, we can see that only the changes that were initially pushed from main branch are there now. But if we push again, you can see the new changes that have been pulled in from new branch. Alrighty, so that's the kind of basics of branches. I hope that makes some sort of sense. Yeah, does anyone have any more questions at this stage?
Someone's asked, do we need to create a new branch if we work independently?
It kind of depends on what you're doing. If you're working in a kind of big group project or even just a small group project, yeah, it's generally a good idea so that your work doesn't affect each other. So if you're both working on the main branch and then you've got conflicts in terms of like you both change a specific line and you try and kind of pull those together later on, it's going to be quite difficult. But if you're working in different branches, you can sort out who's done what and make those changes with git merge. So yes. Any other questions?
What if you're working independently, so not in a group?
Independently, branches are less useful. They're still useful for kind of organizing your thoughts in terms of, sorry, this appears to cannot focus. They're still useful for kind of organizing your thoughts in terms of this is a specific thing that I'm working on, so I'll put it in its own branch so it doesn't affect anything else. But they're less useful because you're not really going to be overwriting like your own work while you're working by yourself. So it's kind of up to you. If you're working by yourself, then just staying on the main or master branch is perfectly fine. Anything else?
There was a question earlier, would you run similar git commands if you're using Jupyter Notebook? My understanding is that with Jupyter Notebook, there shouldn't be any issues and it's the same as any other file.
Yeah, I mean, if you have a Jupyter Notebook file, so an pynb file, yeah, you should be able to just run git commands against that. I don't think you can run git commands from within a Jupyter Notebook, but you should be able to run them just against that file.
Someone's asked, how can we go back to an earlier version of our code?
Alrighty, so that is with the git reset command. So you run git reset. So git reset and then the ID of the commit. So you can get the ID of the commit from git log here. And then you just run git reset and then that ID. Do try and be careful when you're doing this though, because if you kind of mess up with it, you can lose information. Git reset won't change the files in your working directory to that commit. It'll just kind of move git itself back to that commit. If you want to change the files in your working directory back to that commit, then you run git reset. Like that. It's really, really important to be careful when doing a hard reset because that can actually lose information.
Someone's asked, can we use GitHub as a file sharing center since we can use git push everything?
Yeah, I mean, you can. It depends on what you're sharing. It's probably not going to be very useful to put PDFs in Git. GitHub also has a kind of soft limit of 1 GB per repository. And they'd probably frown on using it as kind of a replacement for Google Drive. And they may block your account in that case. But you can basically store most things in Git, yeah. Any other questions at all? I guarantee if you're thinking of a question, a lot of other people will be thinking it as well. So do ask it. Don't feel embarrassed.
I have a question.
Oh, wonderful.
What if someone else has made a change and you want to get that change to your local version?
To your local version, alrighty. Well, that's with the git pull command. So let's do a demo. Alrighty, so I'm gonna, let's see, I'm on the main branch here. And I'm going to save this, git. Alrighty, so I've pushed code. Okay, don't do a hard reset. It's very bad. Alrighty, so I've pushed these changes to the main branch on GitHub. That whole red and yellow thing is because I did a hard reset earlier, which GitHub doesn't really like because it can lose history. It's really not a good idea to do a hard reset when you absolutely don't need to. So yeah, please don't. Alrighty, so I've got all this code on the main branch. Now, if I want someone else to look at that code, so if we go to the repository in GitHub, you can see here the code button, so, get code. Now, GitHub has introduced a GitHub CLI, which is their new default option. Most of you probably won't have that installed, so go to the HTTPS option and copy that link and go back over here. So I'm going to clone that, so git clone. Now, git clone is a way of getting everything in a remote repository and kind of recreating a local repository based on that locally. So git clone, and then you just give it a link to the remote Git repository. So I'm going to clone that demo repository somewhere else on my computer. So not to the same place, just somewhere else. And you can see it's exactly the same repository. You can see the commits. Yeah, same repository. Now, if I want to make a change to the original repository, so I'm going to add a C. This is definitely not valid Haskell at this point. If anyone does know how to write Haskell, please correct this. Right. So I'm going to add this change and push it back up to GitHub. So git add dot, git commit. Now over here, I want to get those changes that I've just pushed. Now I'm doing this on the same computer in a different folder, but generally this could be a completely different computer. This could be someone on the other side of the world. This could be anything at all. Yeah, so the way to get those changes, and we can see that we don't have them already with git log.
You haven't pushed those changes, Samuel. You committed them.
That's a great point, yes. You do need to push your changes. There we go. Okay. So we can see we don't already have those changes. Now, if we want to get those changes, we run git pull. So this will pull all latest changes from the repository. Yeah, and it gives you a wee summary of what's happened. So the hello world.haskell file has had some changes. Yeah, I've only got the original repository open here, but if I open the other one, there, you can see they're exactly the same. Alrighty. Any other questions? Or does that answer your question?
That answers my question, yes.
Wonderful.
Someone's asked about the GitHub GUI instead of using the command line.
In what sense? Oh, right, okay. I mean, you can use it for quite a lot of stuff. You can use it for, it gives you commands to kind of copy paste into the terminal. There's a lot of stuff you can't really do on the GitHub GUI because it's a website. And a lot of the times you're going to be working on kind of local code on your computer. Quite a lot of editors have integrations for Git that makes it easier to do. So for instance, VS Code here has the Git tab that shows you all the changes in that session. You can do a commit just by clicking tick, and it gives you a message if I make a change to show. So like that. So this shows you what's changed. It gives you a wee summary of the change. You can write in a commit message. So this, and then with the tick, you can commit that change. And yes, and then you can push. So there are a lot of GUIs kind of locally that give you a lot of power with that. VS Code has that kind of simple one built in. If you're a student, then the GitHub Student Developer Pack has a lot of, if you look up, that has a lot of Git GUI clients you can download for free. But in general, it's probably a good idea to get familiar with command line because you'll be using it for a lot of other stuff as well. So it's, you know, a good investment that'll pay off in the future.
And on a related note, what's the difference between Git Bash and Git GUI?
So Git Bash and Git GUI, as far as I know, are Windows things. That'll be because Windows itself, I'm not going to say it's a terrible operating system, but is an interesting operating system that doesn't include very good command line tools. So Git bundles its own command line on Windows. So Git Bash is essentially just Bash for Windows, where you can run Git commands. And Git GUI is, as far, I haven't used Windows in like 6 years now, so I'm not entirely certain. But I think Git GUI is just a simple GUI wrapper over Git from Git itself that you can use. I wouldn't really recommend using it. Try using a more fully featured one, I think. Git GUI is quite basic.
Yeah, and just to clarify, the GitHub GUI is the actual website that you see, and Git GUI is something different. Git and GitHub are different things, so you got to be careful about what you're talking about there. Someone's asked about adding people to a private repository. I believe that's just in the settings.
Yeah, go to settings, go to, well, let me make this a private repository first. Okay, let's leave that. Yeah, I think it's just settings, manage access. Okay. It's somewhere in the settings.
Yes, so it'll depend on whatever remote repository you're using. So for GitHub, you can just Google that and it should come up in the search results there. Someone has asked that, so they've added a file to the staging area, but then edited the file. Can they see the changes between the modified file in the working directory and the file that was added to the staging area?
Yeah, I believe so. So let's see. So you've got a file here, and right, let's change this again. So a file you've added to the staging area, sorry. Okay, so git. Okay, so now I've added that file to the staging area. If I run git log, well, I mean, first off, in a lot of editors like VS Code, it'll give you this kind of indication of what has changed here. So it gives you a quite nice representation of the changes, which is probably the easiest way to see it, to be honest. But if you want to do it from the command line, you can run git diff. So if you copy one of the commit IDs that you want to check, select you, that's not going to do that. Okay. Yeah, probably the easiest way is to look at a GUI like VS Code or any other Git GUI and just see the changes. But the actual command to do is git diff, which has quite a lot of options. Probably too many to go into right now, but if you look it up, you'll be able to look at them.
Yes, and git diff and then the file name, for example, git diff helloworld.haskell will give you the differences for that specific file between the current working directory and the last commit, I believe. Apparently no differences because you didn't commit anything. So it's between the last commit. So it won't show differences between the staging area.
Yeah, I'm not quite sure how you would show a difference between the staging area and the last commit, to be perfectly honest. I think there's a way, but I wouldn't know off the top of my head. Between commits, yes, this would do it.
Yeah. Someone has asked, so if they have committed changes with a message, is there any way to change the message, and is there any way to delete the last commit completely? And they've asked about git stash doing that.
So git stash doesn't delete commits. Git stash takes all the changes in your working directory and kind of stores them somewhere else in another kind of repository or staging area and just kind of puts them off to the side while you can continue working on whatever is current in the repository without being affected by kind of little changes you made in the working directory. Git stash is usually when you just want to kind of, you're kind of experimenting, but you want to upgrade your code to the latest version. And then kind of pull your experiments back in without making a commit because it's not ready for that. In terms of deleting last commits, it's really probably not a good idea to do that because if anyone else has that commit tree, so if you push it to GitHub, you'll have to reset it on GitHub. If anyone else has cloned it from GitHub, they'll run into issues. So it's probably not a good idea to delete commits. And in terms of changing commit messages, you absolutely can do that. If it's not the previous commit message you want to change, it's a lot more complicated. But you'd have to do a rebase. And again, a rebase is a lot more complicated than we can get into now, but you can look that up. But if you want to change just the last commit message, then that would be git. Let me just double check the syntax. There we go. So you use the --amend addition to the git commit command, which will change the last commit message. and you can see that in the Git log.
Great. Someone has asked if you can show how to link a local repository to a remote repository.
Sure. So the first thing you want to do is create that remote repository, whether it's with GitHub or with GitLab, Bitbucket, whichever kind of hosting thing you're going with. And I can just do that again from here. So new repository, give it a name. Public or private, create repository. And this gives you kind of a set of commands to copy paste. I didn't go through them before, but I will blow this up and go through them a wee bit more. So the first command is kind of the most important. This does git remote add origin. So git remote is referring to kind of like the remote repositories. Then you're adding a new remote repository and you're giving it a name. So origin is the default one, which is generally what you want to be using. Unless you've got, multiple, you can name them whatever you like. So that adds this remote repository as this kind of origin. Git branch main, this is the new thing that GitHub has introduced. It's specific to GitHub. You can mostly ignore that for any other purposes. And then git push u origin main. So this pushes your main branch or your master branch to the remote repository that's called origin. And then it sets that as the default push target for any kind of further pushes from that branch locally. So if you in future want to push to that remote repository, you just need to run git push. You don't need to run git push origin. Does that make sense?
Yep. Great, yeah. So someone has asked, why do we need the staging area at all? It seems that we always do add and then commit. What's the point in add? And as a follow-on to that in VS Code, you can commit directly without using git add.
Yeah, absolutely. The staging area is really kind of not necessarily useful for all projects. The staging area is quite useful in that you can, there's a lot of complexity there and a lot of advanced functionality there in terms of just adding specific line numbers from a file to the staging area and only committing the specific line numbers and doing kind of weird stuff with that. If you're just doing kind of simple stuff, you can completely omit the staging area. You can run git commit a to just commit everything directly, and then with which has not worked because I've got nothing to commit, but that would work if I had something to commit.
I will say for me personally, sometimes I'll go a little while without adding things and committing things, so I find it easier to add specific files and commit those as I go through a bigger change that I've made, rather than committing a lot of changes that aren't linked together very well.
Yeah, absolutely. The idea of a commit is kind of something that's independent and functional by itself. So if you're adding or fixing multiple bugs, you want each bug to be its own commit. You don't want to kind of mix different bits together into different commits. Yeah. Any other questions?
There haven't been any in a while. Can give it a little while to let anyone come up with anything. We still have around 10 minutes. Perhaps in the meantime, you could give us any links to places that are useful to look at for resources,
Yeah. Alrighty. So the most useful place is a website called git-scm.org, which is the Git website. So this has all you need really. It's got the documentation for Git, which gives you a reference manual, which gives you kind of the documentation for every single command. So you can go and dive into a specific command and look at all the options you've got. So you can see that, even an add command, as simple as that may seem, has all these options. It also has, let's see, a quick cheat sheet, which is not loading for me. Okay. Yes. Well, there's quite a lot of useful stuff on this website. It's also got a book which kind of goes through everything in a lot more detail. And that's all available online. So that's kind of the most useful website, really. And then in terms of remote Git repositories, you've got GitHub. So that's github.com. You've got GitLab as well. And then Bitbucket as well, although Bitbucket is less popular than the two of those.
And if you're using GitHub, definitely sign up for GitHub Student. You get a lot of free stuff like domain names and hosting and things like that, which can be really useful.
Yeah.
Cool.
Righty. Well, if there aren't any more questions, then I think.
Yep, I'll just share the social media again. So if you mind unsharing your screen, Samuel.
Oh, sorry, yes.
Yeah.
And that is the wrong link.
And yep, so that is our social media. So you can follow us on there for all of our coming events. And some of the ones that might be useful for people are the Newton application skills workshop. So that'll be good for applying to places. And along with that, the Bloomberg CV skills workshop. Both of those will be great for internships, graduate jobs, all that kind of stuff. Feel free to ask any questions. We'll be around for another couple of minutes. But if you don't have any, thank you so much for attending, and hope that this was a useful workshop for you.